Welcome back. So in my previous video I had done till the formation of 3-phosphoglycerate. So now I am going to continue my structures. So I am writing 3-phosphoglycerate. Please have a look at it. 3 carbon. You have to write 3-phosphoglycerate. C double bond O, O minus, CH, OH. Third carbon CH2O, PO3, 2 minus. So this is the structure of 3-phosphoglycerate. So this 3-phosphoglycerate, what happens in the presence of an enzyme known as phosphoglycerate mutase. So I am writing the enzyme name now, phosphoglycerate mutase. In the presence of an enzyme known as phosphoglycerate mutase, the PO3 here in the third carbon atom, this PO3 gets transferred to second carbon atom. So first carbon, second carbon, third carbon. So mutase does this role. PO3 from the third carbon atom, mutase transfers PO3 from third carbon atom to second carbon atom. So resulting in the formation of 2-phosphoglycerate. 2-phosphoglycerate means you have to write again from starting 3 carbon. Okay. C double bond O, O minus. Second carbon atom H, O, PO3, 2 minus. Third carbon atom, it is CH2OH. Okay, see now here in the third carbon atom, when PO3 is present, it is called 3-phosphoglycerate. Now PO3 has got shifted to second carbon atom. So resulting in the formation of 2-phosphoglycerate. Okay. Next what happens is that in the presence of an enzyme known as enolase, enolase means this enzyme does the major role of removing water molecule. So enolase does the role of removing of water molecule. So I am going to write the next reaction. This is also double arrow mark. In the presence of an enzyme known as enolase. Enolase removes a water molecule in the presence of Mg2 plus ions. So water molecule, where the water molecule gets removed? H from here, OH here. So H2O, OH, H. H2O is removed. Enolase does the removal of water molecule. H, OH. From here, from 2-phosphoglycerate, water molecule is removed. Enolase does this role of removal of water molecule. So rest of the compound is same. So this compound's name is phosphoenol pyruvate. This is a very high energy intermediate formed in glycolysis process. So phosphoenol pyruvate. The resulting compound is phosphoenol pyruvate. 3 carbon. The rest of the thing you have to write as such. Water is removed. O, PO3, 2 minus. C, double bond, H, CH2. So this is the structure of phosphoenol pyruvate. You can call that as PEP, phosphoenol pyruvate in short. This is the structure of phosphoenol pyruvate. This is a very high energy intermediate formed in glycolysis process. So, the last process is the conversion of phosphoenol pyruvate to pyruvate. This is also a very major reaction, also called as substrate level phosphorylation, because because of the substrate level phosphorylation takes place in this last step. It's a very important step because ATP is synthesized in this step. Why it is called substrate level phosphorylation? Because using substrate, ATP is synthesized. So, for using phosphoenol pyruvate as a substrate, ADP gets converted to ATP. ADP gets converted to ATP. So, another molecule of ATP synthesis has taken place in this step. So, this is a very major step known as substrate level phosphorylation. Substrate level phosphorylation resulting in ATP synthesis. Okay, here ATP is formed. The last product and the final product formed here is pyruvate. The enzyme involved there is pyruvate kinase. Here the enzyme involved is pyruvate kinase. Wherever kinase enzyme is involved, you have to write Mg2 plus ion. So the last compound is pyruvate. I am writing the structure of pyruvate. C double bond O, O minus, C double bond O, CH2. So this is the last compound for a pyruvate. This is the last process of glycolysis resulting in the formation of pyruvate. So at the end, overall the net yield of ATP in glycolysis is 2 molecules of ATP. So the NADH and H plus released here in glycolysis in turn enters the electron transport chain. So here ATP synthesis is the major things that everyone should remember. So overall reaction of glycolysis, the net gain of ATP in glycolysis is 2 molecules of ATP. Thank you.